All right, guys. So what we're going to move into is Chapter 7, the human population, and the learning targets for this are going to be explaining the factors that limit the potential carrying capacity of humans on Earth. We don't have what a true carrying capacity like animals do. We're a little bit different with how we do it. We're talking about that on our first slide. We should be able to describe the drivers of the human population growth, whether it's positive growth or whether it's declining, and you should be able to read and interpret an age structure diagram. So when we first look at the human population, any population rather, you should see exponential growth. That's that J-shaped curve growth, where the growth starts out slowly, grows at a fixed percentage. Each generation, that percentage represents a larger and larger number of individuals, and you get that really, really tall peak, straight up and down line almost of growth, that J-shaped curve. But what we have happen is eventually resources start to become limited. So as resources become limited, whether it's space, whether it's mates, food, water, sunlight for plants, whatever it is, what happens is instead of it being true exponential growth, it eventually starts to stabilize out and we get that more logistical curve. Because again, the carrying capacity kicks in and those limited resources determine what the maximum population size could be. So it's going to grow at its biotic potential, and then all of a sudden those resources become limited, it shifts into logistical growth and steadies out. So in most cases, that's going to happen because we're pretty much always going to run out of some sort of a limited resource. There's very few populations that are going to continue to grow exponentially until they completely die off and go extinct with it. Let's see how I can get to the next slide here. Again, I'm still learning how to do this. All right, so when we look at the human population growth, we started out in the hunter-gatherer days where we were nomadic, traveled with the seasons, and we didn't have a very big population, somewhere around that probably 200,000 mark or so for the whole planet, not just in America, but in the whole planet. So as we went on with time, that stayed fairly constant and steady, small little growth here. We started to get into the agricultural revolution, cities started to form, we started to see, more and more quality of life, people started to work as opposed to farming, and we saw the population start to grow a little bit. We were producing more food, quality of life was improving, we were growing our population. Then Black Plague hits. When the Black Plague hits, you can actually see that the world population took a big dip down. That was a global pandemic that killed off a huge amount of the population. We're looking, I don't know what the exact numbers are, but when you just look at the graph, it looks like about a third of the population died during the Black Plague. Now, when we start getting closer to the Industrial Revolution, that's where the population really started to change. So we hit that Industrial Revolution. Now quality of life's getting great. We have medical care, we have indoor plumbing, we have sanitation's improving, not as many people are dying of preventable causes. So we start to see that really quick exponential growth. And really over the last 100 years, we've put the better part of 7 billion people on the planet, which is just insane to say that we lasted for, almost 2 million years with less than a billion people. And then all of a sudden within the last 100 years, we put almost 7 billion people on the planet. So that's a pretty crazy thing with how fast it's grown. So what made it grow like that are a couple different things. We have population size, the birth and death rates, the fertility rate, life expectancy, and migration. As the life expectancy increases, we start to really see that rapid climb. And that's sort of what happened with our exponential growth over the last 100 years. It wasn't that we had any more births happening. We had about the same number of births. People were just living a lot longer. So instead of the people dying off when they were 50, now they're living until they're 75, to 85. So we're keeping those extra people in the population, not taking them out, new births coming in, compounding in on it, causes the population to grow exponentially. The fertility rate is what plays into that. So when we look at the fertility rate of a country, we want to see it close to that replacement level rate. The replacement level rate is the amount of babies it takes to replace the parents in the population. And for the, I shouldn't say developed, for the industrialized world, it's about 2.1 kids per family. And in the less industrialized world, it's somewhere around that 2.5 range. And they're a little bit different. We'll talk about why that is when we talk about fertility rates more. So we look at the birth and death rates, see how that's going to happen. Birth and death rates are affected by life expectancy. Then we also have to take into account the migration. When we're looking at an individual country, we have to look at the migration for it, whether it's immigration or emigration. If we're on the global scale, we don't worry about migration because the global population is not going to change by people migrating from one place to another, unless we have a new population of humans that we didn't know about come in from outer space, which isn't going to happen. We're not going to really worry about migration from a global standpoint. So the people that study all this, they're going to be our demographers, and they're using demography to study these trends. And most of it's just trend analysis. They take censuses every 10 years or so, but for the most part, they're just making estimations based on what the data gives them. All right, so the factors that affect the population change. First one is going to be immigration. So I need a cup of coffee here. First one's going to be immigration. That's going to be I for into. So those are the people moving into a region from another country or another region. Emigration are the people exiting an area. So in order to have immigration, you have to have emigration from someplace else. So the people emigrating or exiting from that one country or region are immigrating into a new one. Those are going to be, again, adding to the population, taking away from the population. Now, we could count the births, but it's really, really hard to do that because there's so many births that happen each year. So instead, what we use is something called the crude birth rate. We look at 1,000 individuals in a population and see how many births happened within that 1,000 people. That gives us a better extrapolation of what the birth rate is going to be. It doesn't give us those huge exact numbers, but again, we're looking for estimations within it. That's going to add to the population as well. And the same thing with the deaths. We look at the crude death rate as well. So the number of deaths per 1,000. And when we look at all that stuff, that gives us an estimation of how the population is going to change with time. So to put it into a mathematical formula, we look at the inputs versus the outputs. So we're going to take the births plus the immigration, subtract out the emigration and the deaths, and that's going to give us our population change. Right? That's going to be a pretty important equation because, again, that's going to allow us to figure out how the populations will change. We can estimate how the populations are going to change, saying it's going to increase or decrease by looking at the age structures, but this gives a more exact value. So when governments are planning for infrastructure and when governments are planning for social programs, they would use this type of equation more so than looking at the population pyramid. They would look at the population pyramid as well, but for the most part, it's just going to be, they want more exact numbers. Even though these aren't true exact, they want to be a little bit more precise in how they're recording. All right, so when we look at the changes, it's going to be a little bit different when we take into account the crude birth and the crude death rate because, again, those are per 1,000. So we're looking for a percent change, basically. So we're looking at the crude birth minus the crude death. And again, this is the global population. So we're not taking into account immigration or emigration. You take the births minus the deaths. And since this is per 1,000, instead of dividing it by the 10, instead of dividing it by the 100, we're only going to divide it by 10 because we're looking at the converting it into the percent form. So since these are already represented per 1,000, we want it to be per, that fraction of 100 with that. When we look at the national growth rate for an individual country, this is where we want to take into account the immigration and emigration, because now we want to make sure that we're counting the people not only born in the country and dying in the country, but the people coming in and leaving as well that are still alive. We're seeing more and more immigration happening across the planet as environmental refugees are starting to pop up. Your island that you live on is starting to flood out. You need to move due to environmental changes or climate changes affecting the fishing in the area, and there's no more fish to eat, so your food sources are going away. We're seeing a lot more people immigrating to new areas because they had to leave due to the environmental conditions. So these will tell us our growth rates. Now, the other important thing that we want to know is how long it's going to take for a population to double. So when we look at the doubling time, it's the rule of 70, they call it. And the rule of 70 shows up on the AP exam all the time. So make sure that you know this one. Know all of these equations, but the rule of 70 definitely shows up almost every year on the AP exam. So to calculate the doubling time, the amount of time it's going to take for a population to double, it's going to be 70 divided by what the growth rate is. So you're going to first calculate the growth rate from up here, and then take 70 divided by that. You still want to look at it and leave it in percent form. I know in math you usually put it back in the decimal form, but leave it in percent form, and we're going to take 70 divided by that, and it's going to give us that rule of 70. That's going to be important because if we're looking for how long it's going to take to double, for instance, we started with like 2 billion people in America back in the 50s, and then in a short period of time, that 2 billion people doubled to 4, and it was only like 30 or 40 years. If we can estimate how quickly the population is going to double, we can get a better idea of what kind of programs we need to offer and what kind of infrastructure changes we need to make. Now, what goes into that crude birth and crude death rate is our babies being born, and that's going to be our fertility rate. So every woman on the planet has some sort of contribution to the fertility rate. Even if they're not having a baby, they're still going to contribute to the fertility rate because you're looking at the average number of children that each woman's going to have in her lifetime, in her childbearing years. And again, we said the other day that it's somewhere between 14 and 55 that we're looking at. Yeah, that could change a little bit. You could have lower than 14, you could have higher than 55, but for the most part, it's somewhere around 14 and 55. So we're looking at the childbearing years. So whenever they're fertile, we're going to look at how many babies on average they're going to have. Again, in the industrialized world, ideally, we want to have it be about 2.1. In the less industrialized world, somewhere around 2.5, because we want to just replace the parents. That's going to be what's called our replacement level fertility rate. It's the number of babies it takes to basically cancel out your parents. Your parents are eventually going to die. I know that's a sad thing to think about, but your parents will eventually die, and everybody will eventually die. So we're looking at replacing them in the population because we don't really want the population of the planet to change. We're already over consuming resources. So we want to keep that population steady and stable. So we look at having the replacement level fertility rate met. And again, 2.1 industrialized world, 2.5 less industrialized world. Think for a second, ask yourselves, why does this work this way? Why is it higher in the less industrialized world than in the more industrialized world? Hopefully, you guys came up with the fact that we have a higher infant mortality rate in the less industrialized world. Kids are going to die from the flu. Kids are going to die from diarrhea. I know it sounds funny, but people poop themselves to death because they get diarrhea, they dehydrate, and they end up dying as a result of it. Diarrhea was actually one of the leading causes of death in America up until really about the 1900s. And then as we started to get indoor plumbing and sanitation increased, we started to realize what was making us sick. We kind of took that cause of death and lowered it down some. In the less industrialized world, that's still a big cause of death because children especially are very, very prone to dehydration and problems as a result of it. You know, they can't go to the doctor and get some Pepto-Bismol and go to the grocery store and get Imodium or Pepto and have that diarrhea go away. Instead, they have to kind of, hopefully they can hydrate and keep, from dehydrating and dying. So when we look at that, since we have such a high infant mortality rate in those less industrialized countries, it takes a little bit more kids on average to replace the parents. Now, we still do have deaths of children in our country, which again is a sad thing to think about, but we do have those deaths happening. So we need to have ours slightly higher than 2.1, or slightly higher than 2. So on the AP exam, they try to trick you up a lot with that. They'll say, what is the replacement level fertility rate? And everybody instantly thinks, oh, it's going to be 2. I'm replacing my parents. No, it's slightly higher than 2 due to the fact that not all those children are going to survive. All right, now, when we look at our growth model for our world, this is where the scientists are all disagreeing, this range of population estimation. They're saying somewhere between 7 billion and somewhere up in the range of like 10.5, 11 billion. Some people are actually thinking our population is going to start to decline over the next, 50, 80 years or so. As we start to get into that post-industrialized world, people start having less and less babies, and they're thinking that once all the countries get to that status, we're going to start seeing the population decline a little bit, or we're going to be doing so much damage to our planet that the population just won't be able to support it. So if you look down here, again, somewhere between 6.8 and 10.5 billion. Most of them are saying, though, that it's probably going to be around that 9 billion range, right around in here. That's where, again, we look for 97% of the scientists agree on something. Once you get to that range, it's almost a certainty that that's going to happen. We're not quite to that 97% certainty, but a lot of them are saying, we'll probably be at 9.0. Even at 9.0 billion, we've got to make changes to our lifestyle because we're currently at about 2.5 planets needed to meet the lifestyle demands of everybody on our planet. Again, the more affluent a country is, the more resources they use. So the wealthier, more affluent people are over consuming resources. They're being counteracted by those poverty-ridden, poorer people. But as more and more people gain middle-class status, we're seeing that resource usage go up. So we need to change our lifestyle in order to be able to have the planet support that range of people here. All right, so life expectancy, how long we can expect to live. Global life expectancy, I think, is somewhere around 72, 73 years right now. It's drastically lower in some countries and considerably higher in other countries. Last time I looked, I think Japan was somewhere around 90 years almost. So that's just crazy that when you're born into a population, you can expect to live for 90 years. We're seeing this life expectancy climb on average across the planet because our medical care is getting better. We're starting to understand disease and illness more. We're having more treatment of cancers. We're getting cures for different diseases that are out there. So our life expectancy is climbing. It's still drastically different in the less industrialized and the more industrialized. The more industrialized a country, the higher the life expectancy tends to be. And again, that gets into quality of life. With the obesity epidemic in America, we start to see our life expectancy kind of still lagging behind a little bit from what other countries are, even though we have great medical care. We're still not living that healthy lifestyle overall. Now, there are a lot of people that are healthy and active. Those people are kind of counteracting people like myself who are a little bit chubby and run the higher risk of dying earlier. The two big things we want to look at, though, because they determine the quality of life of a country, are the infant mortality rate and the life expectancy. The child mortality rate's a little bit different. We don't take into account this one as much. The child mortality rate is those that die before they get to age 5. It's per thousand. Again, we always use the crude rates for these. So it's always per thousand. So the number of children that die before they reach their 5th birthday, that's the child mortality rate. So that's not going to give us as good of a picture of quality of life of a country, because once you get over a year old, you're going to have a better immune system. So, you're going to not die so much from those preventable cold bugs and flu bugs and things like that. When you're an infant, though, this is where you're extremely susceptible to those illnesses, the cold, common cold, the flu, things like that, that normally wouldn't kill somebody with a little stronger immune system, but it does kill off infants. So when we look at the children that die under their 1 year of age, now we have to see what's causing that to happen. Most of the time, it's poor quality of life that causes that. In America, those children that die under 1 year of age, odds are they had some sort of a birth defect, some sort of a terminal illness as they were born, because we have the capacity to treat them and help them from getting sick and dying off. So in the less developed countries, if we have a higher infant mortality rate compared to America, we look at those and say, all right, what's causing this? Odds are they don't have indoor plumbing. They're still using outdoor outhouses. Those outhouses may be too close to their water source. Whenever that happens, you can get Giardia and E. coli and a bunch of different pathogens that enter into the water supply. You drink that water and you end up getting sick from it. Or, they get a flu bug that passes through the family. The rest of the family survives. The infant's so small that it affects and kills them. So the two big indicators of quality of life of a country are life expectancy and infant mortality rate. The higher the life expectancy and the lower an infant mortality rate of a country, the better the quality of life is in that country. Again, these are the two best indicators of that. And that's an important thing because that showed up on the AP test a couple different times in the released exams that they put out. So make sure that you guys understand, again, when we look at quality of life, the better the infrastructure you have, the better the quality of life. The better medical care you have, the better quality of life. So we look at the life expectancy and the infant mortality rate combined. All right, so when we look at the life expectancy across the planet, again, the greener it is, the higher the life expectancy is. So when we look at America, we have a pretty good life expectancy. We can expect to live about 76 years. When you look at Japan, where are we at here? Over in here, Japan is going to be considerably higher than that. They're going to be at that extreme end of that life expectancy. As you can see, the life expectancy kind of follows with industrialization. North America, highly industrialized, huge amount of money. We have a higher life expectancy because of that. Australia, again, higher life expectancy, higher amount of money. Western Europe, same way. When we get into the poorer countries, throughout the rainforest in South America, the poor, more poverty-ridden countries, we see a much lower life expectancy, 60 to 69. Now, when we go to sub-Saharan Africa, we look at those countries over here, and we see life expectancies that are below 50 in some cases, and really don't get above 50 to 59 because quality of life's really not good there. There's hardly any I don't want to say hardly any food. They need help with their uh, food supplies. They have relief agencies that come in. Farming's really difficult. They don't get a lot of water, so farming's challenging for them. They don't have that knowledge base. They're not going to college, so they don't have the doctors that we have. The medical care is not available to them. So when we look at this, our global average life expectancy, even though we have, all that high population range, high life expectancy range rather, in these more industrialized countries, the majority of the people of the planet live in the less industrialized world. So we're looking at, the sub-Saharan African countries with the huge population growth. We're looking at India that has, slowly becoming the most populated country in the world. When we look at those with the grayish shading to them, where they're living only 50 years or so, that's going to drastically reduce the global life expectancy. So we're looking at, high life expectancies in the more industrialized world, lower life expectancies in the less industrialized. And again, that gets into the quality of life. Uh, the more children you have dying, the more that life expectancy is going to be decreased. Now, the other big thing in sub-Saharan Africa is the AIDS epidemic. AIDS is just ravaging the population there because, again, they don't have the access to the birth control that we have. They don't have the ability to go out and get condoms to prevent the spread of AIDS. So as they're being sexually active, they're spreading that AIDS disease throughout the population. And in some cases, we're seeing 1 in 4 people have AIDS in some of these countries, and even a higher rate in other countries. All right. Now, the other big thing that we see is our migration rate. Now, in America, our age structure diagram that we talked about, we're slowly getting to the point where I think we're currently around 1.9 for our fertility rate. So we're below the replacement level rate. Our population should be shrinking, but our age structure diagram is still a slight pyramid. So because of that, it's going to take about 40 or 50 years for our population growth to naturally slow down and stop. Once we get to that range, what we're going to see is a declining population in America, and it's going to be similar to Germany and Japan and places like that, where we're declining population growth. So when we get to that point, and we're already starting to get to that point, we need to increase our migration rate. We need to have people coming into our country. We don't want people to exit. We want to make it good to live here, and we want to allow people to come into our country because we're going to need those people to kind of stabilize our population. Even right now, we have a lot of jobs that are open that the American public doesn't really want to do. I know this is a controversial thing, but they don't really want to do them. We always hear the immigrants are taking our jobs and things like that. A lot of the immigrants are filling those jobs that we don't either want to do or we're not willing to do because the pay is not high enough. And I know that gets into that political debate where, if the immigrants weren't coming in, then they would pay higher wages and then Americans would do the job. So you have to kind of balance all that out. That's going to get into more of a social studies talk. But we do need that migration to happen just for the simple fact that when we look at the fertility rate of 1.9, we need to get it to that replacement level rate so our population staying the same. If we have a declining population, our country is eventually going to suffer from it because we won't have as much tax base, we won't have as much workers working the jobs and things like that. So that brings us into age structure diagrams. Age structure diagrams are going to basically describe how it's going to affect the population across those 3 age ranges. Again, the pre-reproductive, the reproductive, and then the post-reproductive as well. So we break them into those 3 categories because, again, those are the ones that are about to have babies, the ones that are having babies, and the ones that are about to pass away and die. So when we map those out, that gives us a population pyramid. And again, we want to split it down the middle and have males on one side, females on the other. Then when we do it, we don't really group it by these boxes. We group it usually in age ranges of 2 years at a time. And then we would just keep on drawing our percent of the population across the X, and then the age ranges across the Y. When we do that, it forms some sort of a pyramid, whether it's a column, whether it's a true pyramid, or whether it's an inverted pyramid. And that population pyramid is what we call that age structure diagram. If it's the widest at the bottom and smallest at the top, that's going to be rapidly growing population. That's what we're seeing in our less industrialized countries, those ones that are still developing their economies. We see rapid population growth because they still need to have extra babies to make sure they have workers on the farms, to make sure that they have income coming in. They also don't have retirement funds. So their children are going to have to support them in old age. All of those reasons mean that they have to have more babies with it. Plus, they have a higher life or higher infant mortality rate. So when they have 5 kids, not all 5 of them are likely to survive. They may only have 4 or 3 to survive. So they tend to have more kids to play kind of the law of averages and also to ensure their long-term survival. We have pension systems in America. When we retire, we still get money coming in. In the less industrialized countries, they don't have that option. So they're going to work to however old they can still physically do it. Once they get to that point, they have to stop working. Once they stop working, they have no money coming in. So they don't have any ability to provide food or shelter for themselves. So they're reliant on their children then to do that for them. The more kids you have, the better quality of life you're going to have in the end. Now, what happens is you end up with what's called population momentum. We said in America, we're at 1.9 for our fertility rate. What happens is as we go through our 3 groups with our age structure, and again, I know I'm skewed a little bit to the female side, just assume that it's straight up and down through the middle. Here, I can fix that. So what happens is, as we reach that replacement level fertility rate, we're at, say, that 1.9 right now, or say we just hit 2.1 right here. We were above 2.1 for all of these different age ranges through here. Those different age ranges have to still make it through the population before our growth rate is going to stop. So what happens is this group dies off. This group slowly inching up. They're still having babies as they go. These pre-reproductive are moving into reproductive age. So they're having babies now. That group of people that were there when we were above 2.1 has to make it the entire way to post-reproductive status. Again, it takes the 55 years old to get there. So usually after you reach the replacement level fertility rate, the population still grows for about 50 years. So we hit that 2.1, and we're still going to see a growing population for about 50 years afterwards because everybody has to make it through that age structure in order for population growth to stop. Let's see if I can pull these across and progress to the next slide here. So we look at these age structure diagrams. This first one here, again, these would be those low industrialized countries. India is the example they give. Rapid population growth happening because, again, we have that bottom heavy pyramid going through. Even if they would somehow make it to 2.1 tomorrow, it would still take another 50 years of growth for them to slow down and stop. When we look at the United States, we're starting to see more of a column shape forming, and we're very, very low growth rate right now. The American population is growing, but it's mainly due to immigration now as opposed to births happening. So even though it's not an exact true column, we can see that if we would squish this down, it's almost a column. So we squish that top part down, and that's going to give us our more column shape. Really, the only 2 parts that we're worried about are the reproductive and pre-reproductive because, again, those are the ones adding people into our population. If those are fairly steady and stable, then we're going to see, or fairly equal, I should say, then we're going to see population growth slowing down. When we look at America, there's a funny thing here. When we look at this age range right here, this was taken a few years back. So this is a little bit older one in 2010. So when we look, it's about 10 years ago. When we look at that age range from about 10 years ago, we see a big bulge up here on the top of it. Ask yourself from social studies what happened, about 50 years ago, and we had the baby boom happening. My parents' generation was born. As they started to be born, I guess it would be 60 years ago now. As they started to be born, we looked at that huge influx of people. The people were coming back from the war. They had huge amounts of expendable income. They wanted to start families up. They started having families. They started having big families. I come from a family of 6. So both of my parents were from families of 5 also. So, they have those big, big influxes of population. That baby boom generation is now moving into retirement age, and that's going to impact our economy because we're going to have to provide more social programs. You always hear that Social Security is going to end and Medicare is in jeopardy of failing. That's happening because those baby boomers are moving through and there's a huge usage of those resources. When we look at Germany, they have what that inverted pyramid looked like. So when we see them, they're more of a top-heavy pyramid, so their population is decreasing. When we look at China, they have a very unique age structure because they had a rapidly growing population They saw that that was going to be problematic for them, so they implemented the one-child policy. When they implemented the one-child policy, now we had that squeeze into the bottom part so that they would slow their population growth. Now, that population growth slowing isn't going to take effect right away. They played the long-term card there. They knew it was going to take 15 years before those new babies were going to get in the reproductive age. So they were looking long-term to slow their population growth. The problem with it is, if you look at the distribution of males to females, we're looking at about 46% male and about 40% or so female. I don't really know where the other, well, I guess that yeah, I don't really know where that other, what would it be, the other 4 or 5% goes, but we're looking at, that would probably be the infant deaths and all that stuff, because again, they were taking kids into the countryside, abandoning them, female children, abandoning them, and sometimes even killing them. So we see that gender imbalance. That causes problems because, again, when we don't have mating pairs where we have a male and a female, that's going to spell problems because we can't find enough people to replace our population. So that's going to affect the fertility rate as well. All right, now I think we're going to hold off on module 23. I'll make a second video up and we'll put it on there because about 30 minutes is about a maximum I can get you guys to pay attention for. So we'll pick up with module 23, which is going to be our economic development. It deals with something called the demographic transmission model, which is a huge, important thing because it shows how countries change with time based on industrialization. So we'll go ahead and end there for today, and hopefully you guys understand this. If you don't understand any parts of it, please come in during QRT and ask me for some help.